All right, videotaping now. So Cayman wants to learn how to run the CNC machine. And because we don't want to spend money on buying like Mastercam or Visual Mill, we're gonna use this instead. So everybody's familiar with your Euro Good Up modeling setup. And sometimes I'll come back here if I need to edit this guy, but it's rare. Times that I've come back and edited things is if I have like a keying element that needs to move, I'll come back and modify the drum, but most of the time I don't. Or if it needs to be rotated to a certain different degree, like if I do like an index cut top and bottom and I need to move something out of the way or put a support, I'll come back and change this. So typically, like I will build supports in my model and then like flip them away later, because you're just gonna be on the bottom and you're cutting the entire bottom off. You don't need supports, so we will skip that part. All right, cam. First thing you gotta do is set up our machine, and it does have a post processor. So we're talking about Shapeoko. Extra large. So if you go dig around this, you'll find the correct post processor. It allows it to take the G code, which is a very pluralistic GPS for the cutting bit, and converts it to the exact machine. So there's tons of them. I'm gonna get rid of these guys, even though these are the ones that I did. You should pay me for this, but you're not going to. You'll pay me in wood. It's cool. Delete. But that's how I can't tell you how long it's going to take and the complexity until you actually run the post. All right, so let's go ahead and see what we did in the setup. Actually, I'll just get rid of it and do an entirely new setup. Can I? Yeah. All right. Fun thing, every CAD cam is different, so that kind of is the way it is. New setup. So what this guy is, this is your stock. This is the blank material, so it could be walnut, it could be foam, but there's a couple of things you want to get figured out. One, do you want any more excess? So a lot of time I put this at the exact same size of the piece that I'm going to cut, and then I make sure it fits the piece. Or you can make it to your the size of your material you're going to cut. Pretty straightforward. That's in the stock, right? Mm-hmm. How many offsets do I want? These are my dimensions, they match your dimensions. So that's all good. Orientation. This is fun because I like Z to be up and down. That makes sense to me. Since this isn't that, you've got to find a way to make that happen. Select X and Y axes. So, let's see if I can remember. That's my X. That was easy. So X is left and right, okay. Y is up and down, and this is how it's going to cut, right? The Z is going to drop into your material. If it moves left, it's negative on the X. Moves right, it's a positive on the X. So it's your straight up coordinate axis. Very important because it's got to know the orientation. The biggest and the most difficult thing for me is knowing where the origin is in the digital model and relating that to the origin that you place on your physical model. Piece. Yeah, okay. That's the hardest thing, is making sure that they're both communicating effectively. Let's see, origin. So this is where I need to start my tool paths. I like stock box. So depending on excess right now, we already talked about yours, and yours has almost a half. So if this is 0.8, you've got 1.5 inches roughly on yours. So I want my bit to start at the top of this. There are different situations. Let's say you're going to remove this entire piece of wood. I wouldn't advise starting your origin at the top middle, because as soon as you mill it away, you've lost it, right? Mm-hmm. So in that case, I would have a piece that's on the bottom. So I'd origin it on the bottom, or I'd zero it out on the bottom, then come back up and start my tool paths. So I mean, this has to be where you start, because that's what's going to happen in the machine. So let's see. Let me select my... I know we're milling. Come back. Here we go, origin. What it should do is give me, there we go. All right, so box point gives me a myriad of options to pick from. I believe that over God, that's your origin you modeled with. But personally, I like top center. I think on this one, we're gonna do a little differently because you see all this piece is gonna be milled out. I'm gonna pick this spot right there. That way, if you do your first cut with your end mill bit, the one that roughs it all the way away, you can come back, mark it with a Sharpie, come back and make sure you have the same home for both bits. That's the most complicated thing. If you have an automatic bit changer, fantastic, but they cost money, and as long as you understand the process that we talked about the other day, which is get you a V bit, make it sure it fits at that point, that way your X and your Y are good. Come back, take your flat mill, your end mill, which is gonna be flat on the bottom, take a Post-it note, drop it all the way down until it catches. When it catches, you're 0.004 away from your piece of wood. So then say, all right, so I've X out my 0, which is X0, Y0, Z0. I take it and then I can cut. So the same thing can happen when I come back and do the ball mill. I'll place the V-bit, go back to that same spot. It should be the same, but I'm making sure. Then I'll change to a ball mill, which this is gonna work as a ball mill. So that's my X and my Y is good. I drop it down, wiggle it till it stops. Then I know that they are both starting in the same spot. That one's a painful one to learn through mistakes, but it happens. All right, so stock. Get rid of you and keep on messing that up. For the stock, how much offset do you want? 1 millimeter here or there is not gonna matter at all.
What's the offset for?
If you have excess material that you know needs to be removed before you get into it.
Okay.
So let's say you had 1/8 of an inch of material on the bottom, but you wanted to cut all the way through, which we cut into a spool board, which isn't a bad thing to do, but depending on what you needed. Sure. All this does is adding a bit of material, so it's gonna cut down 1 more millimeter on the Z than if I say, hey, start on the top.
Got you.
And this can help because, like, do you know that your piece of wood is 100% flat?
No, or if you're splitting it and you need to cut that piece off, that'll give you a little bit extra for blade width on the bandsaw.
Correct.
Okay.
So this gives you that little bit extra wiggle room, right? We can build it up to 2 millimeter. It's not gonna make a difference, but
just remember, you added 2 on the bottom straight down from it's a profile thing, right?
Yep. Okay. So 2 on the top and the sides I really don't care about because it's gonna cut the outsides. We'll do a tool path for that. Post processor, already embedded in this. I can't remember what it is because I haven't done it in a while, but dimensions, they're accurate. You need to use, especially for the Shapeoko, the normal one, the XL or the double XL, gotta be doing in millimeters. Just, it's the way it wants it done. All right, so now we get to do some of the fun stuff, which is how do we want to pocket, or how do we want to remove material, and then how do we want to finish? Lots of different options. Like Chris Arnold gets up into like the 4 and 5 axes. I don't know how to do that. I'm a 2D, 3D person. Let's see. There's different types. So pocket would just remove material until I got around into these sections, but it's not gonna remove every single thing. Facing is leveling. 2D contour, we're gonna use this to trace the outside, give us a clean edge. That could be the last thing that we do. I'm gonna do that with a ball mill though. Trace, very similar, except this can do 3 axes in tracing. And these I haven't played with, so I'm not gonna talk about them. So we're gonna do adaptive clearing. And so this is where you've gotta know what you're talking about. We're gonna use a 1/4 inch flat mill bit. End mill, I keep on calling flat mill, but it's flat on the bottom. If this is off, everything else we're going to do from here on is going to be off.
Okay.
Right? So you need to know your tool sizes. The biggest thing is you need to know your diameter. That is, without it, you're done. The second thing is your cutting height. It is important, not the most important thing, right? If we're cutting down 1 inch, and this is only 1/2 inch, eventually what I might do is I might plow into the material with no teeth. Bad idea.
Your chuck's going to be hitting wherever you've already cut.
Yeah, so that's the second thing. The third thing is overall tool length. I don't want the collet to hit anything. But chances, if you have a lot of cutting length on your tool bit and you're plenty far away from your collet, nothing's going to happen. So I can come in and edit these things, but it hasn't been an issue. I haven't cut anything longer than 2 inches. If it does get longer, you want to make sure that if you are going to cut every single thing or use the entire cutting width, that you remove the top material. That way, as you're going down, you're not running into uncut material with just a cylinder. So 1/4 inch flat. This little guy, which is starting the origin that we told it to. Coolant. We ain't got none. So we're just able to coolant. I don't think it's going to do anything anyways. Huge information on feeds and speeds. I'm going to leave these as default. You can change them. I'm sure there's reasons to, but like this is like a 30-minute talk. I would just take the defaults at this moment. Geometry, pocket section. So it's looking for, I'm doing pocketing right now? No, doing adaptive clearing. Let's see if it let me do the outside profile. Cool. So it's not going to remove material outside of this piece, which is totally fine by me because I don't want to remove an entire piece. I don't want to spend time cutting things that don't need to be cut.
It's just extra work. It doesn't have to do.
Yeah. What's nice is you have a instead of this being a 3D piece, it's flat, has a flat profile on the back, which essentially means you've got one curve. It's looking for the curve. It says, do you want to cut on the inside curve or the outside of the curve? So cool. Next thing are your heights. Retract height is when it's traveling. So we're trying to think is
that when it goes back to rest? Or when it moves between?
Very close.
Okay.
So top height is obviously the upmost part of your material. Retract height is when it's moving from place to place. So it finishes like cutting a piece over here. It comes up and moves. Mm-hmm. And then the highest it's ever going to go is your clearance height.
Okay.
So you can smush these together, but I'm trying to think of a reason. If you have things that are holding it down, you want to make sure either your retract height or your clearance height are above your clamps that you have.
Gotcha.
Easiest thing is try not to have clamps, but that's not always possible. Everything on here good? Yep. Passes is where it gets fun. Optimal load. I don't know what the optimal load is, but I'm looking for. This one doesn't have step over. We'll get to that in a second. Climb and conventional. Climb means it's pulling material out. A lot of times the bits can be running left and right. One way it cuts really well, one way it cuts but in order to be most efficient with your cut, you typically kind of go back and forth in a zigzag pattern. So it's either cutting material into and then pulling it out or grabbing it out as it leaves. Both work. I find that climb milling works a bit better. And your direction will depend on your drill bit, but typically all are climb bits. Stock to leave. We're not doing radial or axial, so we can leave that alone. Linking. I don't know nothing about linking. Ramp type, instead of it just dropping into material, which I like it dropping in material, it puts a higher load on your bit. But what it's going to do, it's going to swing in. But, you know.
Is that when it goes down a curve surface?
Yeah. Well, it's a way for it to get the material with the least amount of, damage.
Okay.
Pre-drill, we're not pre-drilling where it should go unless it's just a blanked out surface. Let's see. Plunge means it drops into the material, then starts cutting. It can put wear and tear on the bit. Mm-hmm. Actually, for this one, we're going to do a helix. So when it's dropping the material, it doesn't just go in and then turn left. It's going to spin its way in, create a cylinder cavity, and then take it out. So best part is right now it's going to calculate what this toolpath is going to look like. I'm guessing we're going to have to change it. So let's look at our simulation. I'm going to turn my stock on. You see that? For me, that's a no-no. Yes, you can do it with that bit, and it's using all the teeth to do it.
That's a lot of wear and tear.
It's a lot of wear and tear. I like to do it in levels, dropping down as I go. So let's go back and see if I can edit. Multiple depths, there we go. maximum roughing step down. The rule is you only want to step down half the diameter. So that's why that profile is going to be important. Is I don't want to step down the entire, like if this is 1/4 inch, I don't want to step on 1/4 inch. You can if it's foam or really not dense material, but the rule is whatever this is, half it, that's your drop down.
So an 1/8 inch is the most?
Yes.
Okay.
Is it going to take longer? Yes. But the chance of your bit breaking is a lot less. And if you break your bit, you got to order a new one because you can't get these from Lowe's. So just patience. Let's see if I can get it to recognize my region. See all that over here? I don't need it. Let's see if I can get it to recognize a region. Stock contour. Just give me that guy. Chain, good. Run it again. What's my warning? Empty tool bath. Why is it an empty tool bath? I want a pocket inside of there. What is the stock contour? Maybe I'm... Yeah, that's what I want. I want it to do a section instead of the entire thing.